G'day and welcome back. Now, fellas asked me to build him how can I explain this? What he has to do is push a pin out. Now, he's only got about 5 inches of clearance of where he can get in, 5 to 6 inches he said. It's a fairly big pin. He hasn't got a squatted porta power jack or anything like that. So what I'm going to build is a cylinder, basically hydraulic cylinder, that you pump grease into, and you can just use a grease gun and push the piston up, and hopefully that'll release the pin. He said it shouldn't be all that tight, but it is tight if you can get that. Got some material, bit of heavy walled tube. Now, I don't know how good this is going to turn out. It's going to be a completely wing it as we go. I've got to try and get a nice finish in the inside here of this tube, and the outer diameter of the piston has to be a good fit too. So I've been down and bought just a selection of O-rings that I think may work. I've got no idea how to work out dimensions of O-rings and bores and all that sort of crap, so it's just wing it and see what happens. If it works, it works. If it don't, well, nothing's lost. Like a grease gun, I think pushes out about 10,000 psi or something. So there's a fair bit of grunt behind the grease gun. Anyway, get over to the lathe and try and work out where the hell I'm going to start, because I've got no idea. Now, people probably make these things all the time and going, you're going about this arse about front, but I've never made one before, so trial and error. And that noga's nice. Definitely a hard spot there. Yep. Well, I'm going to run with that. I'm going to put a centre bore in it and probably counter bore that just a fraction for a nut. Might pay to take that O-ring off there, eh? Forgot about that. Yeah, pretty rough hole, but it's a hole. That'll be right. So I'm going to shorten the nut down anyway. It's going to be a fine threaded nut. So now I've got to spin this around and machine this crap off the other end. I might just jam it in the 3 jaw. I know it's not going to run concentric, but that doesn't really matter as long as it's straight. Well, there's the piston. It's a touch warm too, just quietly. And you just done that so the indicator's got somewhere a little bit more smoother to run on. So that bit's about 110 long. It's going to be 100mm when it's finished. And you've got to bore the guts out and put a thread on one end for an end cap. Probably going to weld a plug in the other end with a TIG, I'd say, just to block the other end off. What I think I might do is take just a clean up pass, face the end off, spin it around, and then I can clock it in true then. A bit more screwing around, but I think it's worth it. Yeah, you're going to go soon for the glare there, but this ends within about a thou on this indicator. Back here, it's pretty much dead true. I'm not going to try and chase that last bit out. Not quite 100% right, but it is pretty even all the way around, so got it lined up pretty true. Start doing that bore now. It's going to be a whole lot of fun, isn't it? Yeah, no, shit finish. I have to think of another plan. Well, after a lot of trial and error, I've gone back to a high-speed steel boring bar, 110 RPM on the spindle, and a fairly slow feed rate. And I'm hoping that's going to get me a half-decent finish. Well, that was a total failure. I tried everything then, and I just cannot get a decent finish, so put this one on pause, this project or this build, and I've got to quickly build a different boring bar, a stiffer boring bar. So that's what we're going to do. That actually worked. An absolute treat. That's perfect. Now that we've got this internal bore sorted out and we've got a new boring bar, I want to make this so this can be serviceable. So if the O-ring does blow out, you can get it apart. It's not going to have welded ends on it. Well, this bottom end's going to be welded on, but the top I'm going to make it screw on. So this is 65mm. I'm going to put a 1.5 thread on it and build a nut to screw on. yeah, just a ring that screws on with a hole in the guts with an O-ring that the piston will come out, the rod will come out. Not the piston, the rod. So chamfer this and then run a 1.5 thread on it. Well, this piece can actually come out now because I can't think of nothing else that needs to be done to it. I'll go on to make the rest of the piston or the rod now. Then after I make the rod, then I'll make the cap. Okay, so I'm going to put the thread on the end of this. So I've got to turn this back 20mm. I know I'm working in metric and imperial, but it's going to have a 5/8/11, a 5/8/18 thread on here. So I'll turn it down to 0.623, about 3/4 of an inch long. And it's going to house an O-ring in there as well, so it'll seal around the piston. Of course, it's got a bit of chrome plating on it, just covering the ways for a minute while I get under that chrome. So we're under that chrome there. It's pretty hard still, but bring you up to speed a bit. What I went and done is I've put a shoulder here so it registers centrally. I'm going to counterbore the back of this to place an O-ring in there, so when it goes up on this face and the nut gets done up, obviously this piece here is going to be threaded and it'll be shortened up too. It'll seal a piston to the rod and yeah, won't bypass grease with a bit of luck. So I'll counterbore in the back here, which will capture the O-ring, so when it goes up it does squash the O-ring in and we should be pretty sweet. To cut this thread I'm going to use a die. The lathe's set up for metric at the moment, so I'm not going to worry about changing it all over, just to do one thread. Now that was quick and painless. More about a bit of skin off. It's nothing unusual. And I can shorten all this down. The length of this thread, since I modified it, shorten it all down a bit. Going to another 1/4 of an inch of stroke maybe. Goes up nice and tight. I don't think that's going to bypass. I think it'll be pretty good. Righty, I'm going to start and put a 32mm hole through the guts of this, or just a bit bigger than 32 to fit the rod through. So that rod should fit through there now. Bugger all playing it, so it'll guide well. Now I have to open up this end, bore it out for the, and put that 65mm thread on it. A bit of a correction on last week's video, that when I made this boring bar, that I said it had to have 150 thou shims under it in the tool part and the tool holder. Well, it's only 15 thou because I misread it. It was like that, and just misread it, but it's only 15 thou, so I was pretty close. Anyway, I've got this out to full length on this boring bar, just to see, just to give it a fair run, see how it handles having a full length. That was a 1mm depth of cut, now we'll go 1/2. So it's 2mm on the dial. That was alright. It liked it. But I don't think I'm going to be taking any more than sort of 2mm out of a job at once. Anyway, I'll keep going to get that opened up and bring us back when I'm getting close. I reckon it's a final cut. Yep. 63.4. I'm going to relieve a bit in the end there and start putting the thread on. reverse switch is stuffed up in the lathe. The reverse switch just buggered up on the, or stopped working. Pulled the cover off the where the micro switches are, and just a little cam come loose. That was a good fix. That's it. It runs pretty true too. That's pretty cool. We're going to attempt to part this off. Isn't it amazing the difference that coolant makes compared to the oil? Well, I am really bloody happy that come off like that. It's not the neatest of cuts, but I'm amazed how much the coolant made a difference rather than the oil. Very, very noticeable difference. Like them chips never got hot. When I first started with the oil, I could tell they were coming off hot, but coolant is definitely a big help. I put the cap back on the outer, on the cylinder, just so I can face this off, bevel that edge, put a big chamfer on this edge, just to finish it off basically. Yeah, it's within a thou, half a thou. This Noga's beautiful. Man, I wish I had one of these 5 years ago. Okay, I have jumped ahead a little bit and started making the base. I've got to try and keep this under, well, I'm trying to keep this whole thing at 5 inches or below. I'm not real happy with this fit. I made it a bit sloppy, but I intend to take this out to my young fella and get him to run around this with a TIG. So I'm not really concerned about that. So the idea here is get this welded on, but before that I'll drill a hole, machine this end off obviously, nice and flat, chamfer it and so on, drill a hole, put the grease nipple in there, in the side of it, and then drill in, match the hole up so the grease comes out towards the middle. It's the only way I can think to do it, so I know it's 100% sealed. Now if I weld it up, it probably won't be 100% sealed. I'll jam this in here and I'll just finish machining this end off. Just got to take it real easy. That's only a 6mm lip, and we don't want to fly out, do we? That wouldn't be a very nice day. most importantly, did we end up under the 5 inches? Just. She's right on it. Righto, welcome to the dark corner. Centered up on where I want to put this grease nipple. So I'm going to drill 40mm deep with that drill, which put me near the center. Open it up to 8.5 to run this 8th tap in, 8th NPT. So now that's on there, I can work out how high to cut this shaft off. I reckon there's going to do. Pretty perfect. We get that welded up now. I'm bloody tempted just to try to go with myself. I really am. What's worse can happen? Make a mess of it. Have to make a new outer. Because I screwed this dimension, this tonal dimension up a little bit, I've just run a rail centre pops around there. I'll put that in the press and I'll just press it down so it sits on there nice and tight. I'm halfway around. I did have the stuff up there, but I have to spin it up in the lathe and clean that off, screw it up. Anyway, keep going. I think I've got it all. Just let it cool down and spin it back up in the lathe and get rid of my witness marks here. One day I would love to own a better TIG, like a pedal TIG. One day. I'm just trying to marry this corner in. I don't know how well I'm going to get it or whether it's a bad move or not, but we're going to give it a crack. That's it, I'm pulling up there before I screw it. I spent a bit of time, went through a heap of me brass fittings I've got in containers here, and I found a tap T-piece. The idea of that is, instead of having to take the grease nipple out to lower it, just lower it, open the tap up and shoot it into a container, then put the grease back in the cartridge, save wasting it. What I done, opened the tap up, blew this up with air, and shot the jack up, or shot the rod up, and while I still had heaps of pressure under it, just shut the valve off and left it for a while, just to see if this was sealing. Yeah, probably 10 minutes later I come back and it was still up. Had a little bit of spring to it when I pushed down on the top up here, and then opened it up and just exhausted all the air. So it's obviously sealing to a point. How it goes with grease I don't know, but you think if it seals with air it'll seal with grease. If it decides to leak, then I just have to pull this apart and lap the tap back in, I guess, because it's just yeah, it's only brass. You'll be able to lap that in easy enough. But it pays not to throw this old stuff out. Well, I'm going to pump it up and see what happens. It'll take a while for the grease to... There we go. It's going up. I'll put it in the press with a bit of pressure on it, see what happens. Oh, it's got some pressure on it. So I'll let the press off. It had some pressure on it. Oh, that's grouse. Got a bit of RHS here. We'll see if we can just deform it. Right, put that around that way so you can see it. Oh, it's got a bit of weight on it. Just punch this up, see what happens. Might just want to roll out too, I don't know. Find out in a minute. Had some weight on it, eh? As you can see, it started to deform it. Probably wasn't a real good smart idea, that one, but oh well. We'll try it this way. Something's bending. It's actually split the tube, eh? Bring these around. Yep. Squash that, no dramas. Okay, I'm going to try and save this grease with a bit of luck. So I've got a little bit of pressure on the cylinder. It's going to be a messy thing, but anyway, it is what it is. Alright, bit of cleaning up to do here. What I'll do now is I'll put a bit of air up its dot. I'll shoot the piston up, we'll pull the cap off, and we'll have a look, see if there's any grease on top of the piston. That'll be a good test to see if there's any bypassed. We can have a look now, I suppose. Can't see any in there, but there is whey oil here that I put down inside that to lubricate the O-ring. There it is. That's only whey oil. Well, that was a pretty good test, I think, to see if it was going to work, and it didn't bypass the O-ring, so I think we've had a win. I honestly didn't think it was going to squash that the way, or as easy as it did. The grease gun didn't feel like, I wasn't pushing that hard on the grease gun on the handle. And that grease gun's got a fair bit of age to it too, so it might have a bit more power than what I thought. But really happy with that. And it didn't bypass the O-ring, which I was even more excited about. And even something I'm more happier about is there was no little spaghetti rings coming out of here where I've got a hole in the weld. So that was brilliant. I couldn't have wished for a better outcome than that. So I reckon that's going to come in handy. I'll give it to old mate to use, and then I'll get it back off him. Just let him borrow it. Get it back off him, and I might need to push something or bend something one day. I can just use this. So I was going to give it to him and say just keep it, but I think I might just keep it myself. Anyway. Thanks for watching. Hope you enjoyed that, because that was a really fun build. Yeah, I enjoyed it. And I do apologise, this video was a bit longer than what I normally do, but I wasn't going to bust it up into 2 parts. I hope you enjoyed that, and thanks for watching. See you later.